Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about fall of hydropower. So let's dive right into it. Now, what was the dream of hydropower? Well, reality is we used to think rivers are forever because, well, any river that is big, significant, it is go back to mythology. That's how popular and old they are. Basically, if you say Ganga River in India or Thames River in UK or whatever have you, whatever big important river you talk about, it goes back to antiquities, meaning thousands of years. So we had this understanding that rivers are forever, meaning nothing will happen to it. And it will flow 24 into 7 all year round. Like there is no else if but, like it's river, it works, the end. And the only things we knew about is that it could shrink and grow. Like it will shrink in the summer, it will grow in the rain. It will shrink, grow, shrink. It's like almost a cyclical system, but it will never stop. That was our perception of it. And getting power from it, basically, what if we dam it and we get energy out of it? What do we getting as a consequence? Inherently nothing, because there is no pollution, there is no emission. It's green because here's the water comes in, water goes out, the end. There is nothing, there is no change here. So fundamentally it's basically solar energy, because your sun is charging the water by converting into steam condenses somewhere else, and then that cycle repeats. So it's basically solar power with water steps. It's green, it's awesome. That was the dream of hydropower. Let's understand the dam aspect of it a bit better. So what it is, it's just a big wall that can stop water. Now be mindful, water is very powerful, as in it can cut through mountain, and somehow we humans with our engineering and fancy concrete figured out we can just dam the water. It's like, bro, you shall not pass, and it actually does not pass. We are damn good with this. Like it's a miracle thing. Like the amount of reservoir pressure that these dams can hold back is like, are you serious? It's like, damn, like really damn. And the big reservoir that we create behind it, it's there to buffer the flow. What does that mean? That simply means we did figure it out that, there will be time there will have too much flow. There will be time there will be too little flow. How about you make sure the river that is downstream is stable? Or let's say you are feeding the water from the river to some canal structure for irrigation. Well, how do you make sure that is completely stable? Like it is there, it works, you don't think too much about it. You create a buffer that is so big that is like, dude, I can absorb the shock of rainy season and, summer, because again, summer does cause melting of the ice cap. So in some scenarios, especially if you are very close to the glacier, you could have flooding season in summer. So I will absorb that, I will absorb the rain, and then I'll slowly buffer it out, slowly. You don't have to think about it. So your canals, your irrigation canal, your water supply will work 24 into 7 into 365 until you don't have to think about it. So that's the design. That's why we built a buffer. Now buffer has to be sized properly. Again, ideally you want as huge as possible, but given the fact that land is expensive, people just don't want to flood hectares of kilometers of it. So there is a limit to that. And not to mention, unless you are in China, most people will spend serious amount of time calculating how much reservoir we should have. Like again, you want a reservoir that is big, but don't want too big, because again, it does waste a lot of space. And not to mention, if it's not used, if it's not filled up, then what's the point? It costs waste money. So it has to be studied. Now, in ideal scenario, it will allow you to stop floods and recharge in summer. Meaning, if your rivers is like getting overflowing, you're like, dude, I will close the dam, buffer will absorb as much as it can, and then you will drain the buffer slowly over the summer. So summer water level will not go down. So you will have a constant water level downstream of the dam 24 into 7 into 365. So if that dam is controlling any waterways that is used for shipping and transportation, you're good, you got this. Like it won't have a scenario, oh, water level is too low for shipping or water level is too high for safe shipping. No, it's like, I got this. Dam is like, I got you, bro. So that's the idea behind it. Now, higher the water level that you can achieve, like especially small ones are generally just check dams, they have small water power output. But if you make it tall, like really tall, like as in like 100-meter plus tall, you can get GG amounts of power out of it, like really ludicrously large amount of power out of it. I'm talking like, I've seen a small dam that was around 1.2 gigawatt, and the world's largest, as far as I know, is 12 gigawatt. China is claiming they have built something bigger, but again, Three Gorges Dam is like 12 gigawatt hour capacity. So it's ludicrously powerful. So it does allow very large amount of energy generation. And managing the dam, now this is where things get a bit complicated. From design point, it looks awesome. It's like, hey, I just have a wall, there is a buffer, the end. Realistically, it's not so simple. For example, if you do not have good weather forecast, this is a boom device for you. Because if you have a reservoir and you have a good weather forecast, you're like, hey, weather guys are telling me that it's gonna rain like hell. You will be like, hey, open the doors, let's discharge the, like, depending on the severity that is being expected, and again depending how much buffer you want, you're like, hey, how about we discharge from, let's say reservoir is 90% full to 75% full, how about that, how about we give 25% buffer capacity? That's awesome. Now you will, if you have enough pre-advance, generally you require around 24 to 48 hour early warning. If you can get that sort of early warning, you can slowly increase the flow in downstream without causing any damage. You're like, I got this, and then it rains like crazy and your buffer is like, I got this, it absorbs it. But if you do not have good early warning system, you would have a scenario where it's like, for power generation, you were like, dude, let's fill up the reservoir, let's create as much power as you want. If the reservoir was full, now it started to rain, now it will overspill. At that point in time, you're stuck, because again, even if you open the door, it will not do much, simply because the water is overflowing anyway. So at that point in time, you are at serious risk. And if it collapses due to overpressure or overflow, God help you. So there is some serious requirement here. You have to balance the safety and power output, because again, the power outputs of this are what we classify as spinning mass power, meaning there is something actually spinning, and that is actually coupled electrically to the entire grid. So you cannot just turn it on or off whenever you want to. Ideally, you would not want, again, if there is a fault condition, you will stop it, but ideally you do not want to do that. So in sometimes people had received enough warning. It's like, dude, we have to empty the reservoirs for buffer case. It's like, dude, we need power, grid is going down. It's like, let's do it. And this sort of thing happened. And you have to balance all three things out properly. If you do not, like for example, recently China, beginning of this year, it had brutal rain and nobody discharged their reservoir. Nobody was like, hey, all our weather scientists are saying we're gonna have rain like there is no tomorrow. How about we discharge our reservoir to worst case scenario, let's say 75%, let's say drop it to 50%, just to absorb whatever the hell is coming. Nobody did that. Every reservoir was full and every dam had to open emergency spillways, and it just collapsed multiple small dams downstream. That's why you did not get to hear about it, because again, China is very good at censoring people, and if you cripple people enough for long enough, they actually start to believe it. So like, you know, people are saying, oh, it's wrath of God. No, it's bad engineering design. Nobody balanced the safety, power and flow properly. If they had discharged the reservoirs, main reservoir of three gorgeous dams and things that are below it, rain would have been like, that's why these things are built, to design to withstand rain and flooding. They did not. So you have to manage these things properly. Failure to do so will destroy you. So what about the reality? Like, dreams are good, okay? We wanted this, it provided us, it did work. So what about the cost of it? Let's say we actually did it. Like I told you, this is a freaking miracle that somehow we can build something this strong, and it's like, water shall not pass, and water actually does not pass. Let that sink in. Like, water is so powerful, it can literally cut through mountains, and it's like, you shall not pass. And it's like, no, you will not pass, the end. So it does work. Here's the problem. It works, meaning flooding is a part of natural ecosystem. Flooding from human point of view looks very destructive, very dangerous. But from a nature's point of view, it's like, yeah, it happens every month, as in every year. It's like a yearly cycle for nature. Like, for example, how the heck we used to feed humanity without fertilizer. Like right now, every farmer is like, the moment they start planting the crops, they're like, dude, we're going to have this many seeds, we're going to have this many fertilizer, we're going to have this many pesticides. It's like, how the heck we used to do that without fertilizer? Fertilizer is a new thing, then why the heck we need so much of it now? And we used to do farming back then because flooding was happening regularly. Floodplains were the most fertile lands. Why they were fertile? Soil fertility needs sediments. River used to carry a lot of sediments. That sediments were like nutrition that was charging the soil. It was happening yearly, so we did not have to worry about soil. Soil was being recharged, and not to mention it was also recharging our wells, underground water reservoirs. We did not have to worry about it. The river is there. The soil around the river is like reached maximum saturation, so it will not absorb any water. But during flooding, it goes into larger area, it deposits sediments that recharges the soil, and then it slowly seeps into, like, some percentage. Of course, majority of the water will not seep in, but enough will seep in that you will underground water will be stable. Your farming land would be fertile. That's why we used to able to work in a world without thinking about fertilizer. Now we cannot even think about it. And then quality of water also drops, because water is not dead, it's alive in a healthy environment. Even in a free-flowing environment, there is fishes, there are multiple species, there is like whole ecosystem. And the moment you put a dam there, you block it, you stop it, that migration process stops. A lot of things stops, flat out, dead, stop, done. And that ends it. That flat out ends it. It's like, The end. So back in the days, people used to tell stories that they're gonna have a fishing rod and voila. Like I'm talking basic wood, cotton thread kind of fishing rod. They used to get fish out of it because there was so much fish in this, rivers. Nowadays, you would be lucky to find anything simply because every time we dam it, we also leaches, basically removes sediments there. That also fish ecology also uses that. All of that dies over time, and quality of water drops drastically every time you dam it. For example, a river could have, let's say, 1 or 2 dams now. Every dam is stopping so much sediments, there's so much blockage there that by the end of it, it's dead. At that point in time, it might as well be distilled water, but it's not distilled water. Some minerals do flow through it, but it's really dead. So flat out, biological life ends. So our river water, that was like, if it was going through a forest was like, I got this, I'm healthy, I'm very well fed. Now you could have the same water going through it, same river water, but it's like, dude, because it does not have the sediments, it does not have the cycling properly, it does not have biological life, the forest would literally die out. Forest could be like, dude, there used to be a forest, the water is still here, why the heck forest died? Life was sucked out of it. And not to mention, flat out, every dam that we have built, hundreds and thousands of that we have built, all of them destroys all biodiversity, flat out. Be it bird, be it other animals, be it other predators, whole ecosystem, poof, because of dam. Is absolute reality. And not to mention, if any of these dam fail, which enough of them have failed in past that we know, this is a man-made disaster that matches or exceeds natural disaster. Like this is a natural disaster, but it's a man-made disaster when dam fail happen. So you have to understand this. This is serious power that we are dealing with. Consequences of failure, it's brutal. And not to mention, when it's not failing, when the dam is not cracking and things of that nature, it still destroys everything. And that's why, like, Chinese rivers, it's so dead that it's like, you'll be like, dude, this river literally created a culture that survived for thousands of years. Now it does not even know how to survive freaking fishes. Yeah, it's like dam after dam after dam. Like in some mathematics, there's some satellite photos suggest that there are dam every 100 kilometers. That's just stupid. That's just stupid. That's like any probability of chance there was that it's like, life could still return in there. It's like, no. So that's the reality of it. Now, let's come to the dirty part of it, the politics. Now, whether you like humans or not, you have to understand, you have to work around human behavior. You cannot just like, oh, I want this amazing thing, it's amazingly amazing, but somebody will figure out how to misuse it. So you have to be wise about it. Unfortunately, dams is way too powerful. It's like god tier powerful. Like we are actually controlling rivers, floods, droughts. That's power. That's like literal god level power. So it literally creates a scenario where you can create drought situation downstream, or you can create flood without warning. Think of it that way. Like let's say your reservoir is fully charged and you hate the people downstream and you're like, open the floodgates. The end. You just poofed out a lot of people in downstream. And be mindful, this happened literally a few months ago in China when they realized the water was like, because nobody discharged their reservoirs and everybody had a scenario where like reservoirs was like full, so it could not absorb rainwater. They all opened emergency floodways, and consequence, tick tick tick, it literally flooded area. It was a man-made system. That is the sad part of it, because it looks like a natural disaster, but it's not. It was a man-made stupidity. So it does create a scenario where politics plays a way too brutal role into this. And water flow is must for us. For all of us, water is there. It's like we need water. Fresh water is compulsory, not optional, compulsory. Now, we evolved around rivers simply because river was there. It's like, yeah, it could flood. It's a bit rough sometimes, but it's like we used to it. But now there is like water can be blocked. Now, in principle, water should come into a reservoir, gets buffered. Basically, the flow rate changes and the flow rate outside of the dam should be fixed. It's not fixed. It changes also. Why? Because again, water comes out of the basically generators. If generators are going through low load phase, basically let's say at night time, you will literally have less water in the downstream. And let's say even daytime they open the doors to run the turbines. You're like, okay, awesome, but nighttime is still low. So inherently overall the water output level is low. And let's say they shut it down for even 1 day or 2 days, and the dam is not spilling. That will cause a drought. So you have to understand that, like the fact that this sort of images gives us an illusion that we have a lot of water. We don't actually. It's the same amount of water. It's just concentrated in one flooded region using the reservoir logic. But other than that, there is not magically more amount of rain, more amount of water. It's just the same amount. It's just like choked at one point. That means everything downstream is at the mercy of dam. So this sort of water level that used to be there, it's a weapon that anybody can discharge. This is like, okay, poof, done. And that's why rivers that cross multiple countries always get destroyed in this reason. And it has happened. Like Google yourself, how many rivers crosses multiple borders, and they have scenario where people started constructing dam on top of dam just to block the other neighbor. Never country. And again, remove nations. You can understand, oh, we hate everybody on who's not our nation. What about nation inside? Like for example, India, has a nation. It has multiple states. Each state's fighting with each other because one state is blocking other rivers water flow. So you can understand that's brutal. That's real world politics that's happening in my own country, and I'm reasonably sure wherever you live, this is a normal sight for you, where like somebody is controlling the dam. It's like, no, we will not discharge the water. We have to maintain a power supply. This was the reason why China is getting so much drought. It's not supposed to. They over prioritize power over flow of water, and consequence was the water level was so low that it started to evaporate too quickly. Once it started to now everything is gone. So, not to mention this sort of god tier power control on state or nation is brutal, because they will use it sooner or later. They will use it. That's why like wars have been fought over dams, and it's a real thing. It's brutal, and it's a political tool at the end of the day nowadays specifically. So it's something that you have to understand, that you may have good intentions. You may be like, hey, I want to stabilize these people's life. I want to provide them good water supply. I want to give them good energy supply. You may end up creating a tool that after your death just becomes a death weapon or like a death star. So it is something brutal, realistically speaking. And that's why like China is creating so many hydro plants. It's like, and they're not even thinking about it. It's like, dude, if you have a hydro dam after 100 kilometer, there is not enough water there. Like there won't be enough rainfall. There is like, oh, all our reservoir levels are low. What did you thought? There is not enough area for it to recharge, and because nobody is like doing proper planning, proper management, proper weather analysis into your subsystem, the heat wave that is going in China should not happen. That's the whole point of dams. It should not happen, but because they have so many blockages, so many stupidity, it's just cooking themselves to death, literally. So what we can expect in the future? Well, reality is dams are a failed idea. We have to accept it. It's like, it's here, it's real. Every dam that we built destroyed everything. So we know for a fact it's just not right. Ecologically, it's just like poof, got here. It's like a nuclear warhead. It's like poof. And we have already killing rivers at faster rate. So for example, river used to be a thing. That's a thing. It's like, there is a river. Now there, hey, what happened to this river? Like, I'm not joking. Like literally when I was a kid, when we used to travel around on trains, railway bridges are like overbuilt, like they're very tall, and I used to see like water come up to like seriously close. Now I have never seen that anymore. Like I'm seeing to the soil, and like the pillars are very tall, and I'm seeing the surface of that pillar, like the bottom surface, because rivers have dried out. Like hundreds of rivers across the planet is just poofed out of existence. Heck, we are drying out seas. So like thankfully we cannot dry out the ocean, but we can successfully dry out seas, and we have done that. Dead Sea is shrinking, other rivers gone, poof, done. That's why no country that is like driven logically is like, let's make dams. No, people know that for dude, it will cost a few $1 trillion. It will take like working optimally for 30 years to pay back, and yes, we know for a fact it's not going to be there for 30 years. So all rivers are already gone at this point in time, like because primary source of river is snow or ice, like this sort of system, and they are shrinking on alarming rates. For example, this is a photograph of same spot taken in 1989, and in 2019 it shrunk by kilometers, not percentage, kilometers. It has, like, again, there is a percentage value of that, but right now every mathematician is like, yeah, bye-bye majority of rivers by 19 or 20 years, like bye-bye. Now you have to understand, these are the nature's reservoir. Now why is that? Because sun is evaporating same amount of water, the water is going there, it used to condense into ice and then fall. Now ice has this property that you can stack it, meaning you have surface, water falls into it, it flows. You have ice falling, it stucks there. Then you can drop more ice, you can drop even more ice, and you can even more. And that's how, like, this whole spot used to be white. Whole spot used to be white, not this like brown color. And I had like few years ago had the luxury of going to Jammu and Kashmir area. Now there was milestone there, and the milestone always had month on it, like June and like they had 2 months on there. Now driver explained to us is that this month you're supposed to never go past this point, and in summer the month would be like much further back. But here's the deal, I saw that many times. It's like, why? Yeah, it used to be till here. Like literally snowpack shrunk so much that there are milestones now, like and repeating milestones. It's like, yeah, we could not used to come this far by a car this easily back in the day, even in summer. Now we are like, it's like we can go almost touch Himalayas at this point in time. So reality is these are shrinking, and we know the rate, we know for a fact this is done, the end. So what's happening about that water? Well, it's not turning into snow, so we no longer have buffer capability. It's creating flash flood because all of the rain just drops, it just poofs. So that creates a scenario, but we need flood control and water supply. So we have to figure out a smarter way of managing that. It has to be done more wisely. Dam destroyed everything, and not to mention like it became a political tool, and not to mention the ecological disaster. We have to find a better way. And snowfalls are ended, so that's the end game, the end, bye bye. Now again, there will be some year that will like, oh, snow recharged like 1 meter extra. Majority of time, like again, you look at the focus, zoom in, it's like look out from a large space, it's like constant downstream. So snowfall has long ended, so rivers inherently done, and we have to go into rainwater harvesting, like brutally rainwater harvest everything, because that's the only way we can absorb ourselves from basically it will also allow us to recharge groundwater. It will also shield us from very major flash floodings, because again, it's a cumulative effect. If you have 1 meter soil that is absorbing water, no problem. If you have 100,000 meter, it can absorb no matter what amount of rain you pour into it, because that's not that much water column in the skies. So inherently, if we do rainwater harvesting, and I'm talking like whole countries start to do this, we can absorb very serious amount of rains, like very serious amount of rain without that much issue. Now you're like, why the heck other countries block rainwater harvesting? Because rainwater harvesting slows down a river. So meaning you literally drying out a river. If everybody truly starts to do that, that's why there is laws in some countries, specifically in USA and Germany, if I'm not mistaken, that you cannot do rainwater harvesting in some places, because the water is promised to the dam, so it's like contract is 100 years. Yeah, this sort of stupid things happen. So if everybody just like accepts it, like river gone, the end, we just have to accept it, that that's a past tense. Back in the days there used to be river, then we can literally use rainwater harvesting to save ourselves, and it will also recharge groundwater, which will also allow us to reduce our power requirement for water pumping. So we have to accept it. This is like the harsh reality wake up call, but we have to accept it. Like the train has left the station long ago. So this was a presentation on why hydro dam power failed. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.